And I would like to welcome all of you. Thanks a lot for joining my talk. And thanks a lot for the great conference so far. I think we've already heard amazing talks, had great discussions, nice quiz and so on. I'll today talk about drawing diagrams, and my goal of this talk is in the end to give you some tools and some impressions or some possibilities of how to draw diagrams, and then mainly add them consistently next to your code within your documentation. And that's what this talk is about. Also, I try to include some live examples, so there's an interesting part for you and for me. And we'll see how it works out. Some words about myself. I'm Marius. I studied automotive engineering in Stuttgart, here in Germany, and afterwards did my PhD about validation of advanced driver assistance system. That was in cooperation with the University of Stuttgart and ETHAS. I got the chance to work at some different companies, and currently I'm working at ETHAS as a C++ software developer. There we are mainly, or I'm part of the testing team department, where we realize closed-loop hill test systems, so always quite near to embedded software, but my part is more on the simulation level. So we're creating simulation models, and here big parts are written in C++. That's also what my passion is about, writing C++, clean code, structured code, and with many of the best practices we've seen today also. Then, some now and then, I have the chance to give some lectures at University of Stuttgart. During my studies, I got into the High Performance Computing Center, the HLRS at University of Stuttgart, and there I'm quite closely connected to. But now to some motivation of the talk today. What we do every day is writing some source code. That's what we like. But there the story doesn't end. So when having written our stuff, we usually, probably all of us, are using some source version control system. Most of us probably Git. And this is part, probably depending on your setup, but might be part of a bigger pipeline where we have some build tooling following, like Jenkins, that runs our tests, compiles our stuff, and eventually deploys it to somewhere, a download server or whatever. But what goes into our repository is not source code only. Of course, if we have build tooling, we probably want to store our build scripts in the repository too, like maybe you've heard the phrase pipeline as code. So we describe the nodes we want to use to build our code, how to execute our tests, and so on. If I talk about tests, okay, they have to be stored somewhere too. It's also source code. So we track it within our repository. And maybe most of you also automatically create their documentation. All of storing this in a version control system enables us, in no matter which point in time, we can go back, we see we have traceability, we can rebuild any version of the code, which is quite important. Now, regarding documentation, this mainly consists of text, but it doesn't only have to consist of text. So whenever there's the possibility to include some graphics, some diagrams, some images, this is also what improves our documentation. But for diagrams and images, this does not ideally fit into this pipeline. And within my talk, I'll present some approaches how to fit diagrams to explain your code, express your code in a quite intentional way more easily. Short agenda. Some words about documentation. Here a little overview. Of course, I can't. Documentation itself is a quite big topic, but I want to point out some arguments here. Then examples of architecture and code visualization, what I'm meaning with it, and ways of how to draw stuff. Then what's meant with consistency, and the biggest part is diagrams as code. There we'll see the live examples, and we'll sum up with some takeaways in an outlook. So, what is good documentation? I've read quite a bit about it, and I found an interesting web page from Atlassian. Most of you know them, and they have the golden nuggets of documentation, how they call it. It's quite intuitive. I think it's reasonable to point them out here. So these are mainly 3 guiding principles. On the one hand, keep it brief. I think reading documentation is not a thing someone does for the purpose of reading documentation, but he wants to get into the software he's trying to use. So whenever possible, try to keep it brief. Visuals are key, and I couldn't agree more to this. So as you also see on my slides, I'm not a big fan of text. So whenever possible to try using visuals, I think that's a good way. We as human beings, we have our eyes, our biggest sense, or we can capture images way more easily and faster than text representation. And of course, knowing your audience. So it depends who you're writing your documentation or also then your diagrams for. So that's an important stuff if it's for internal development and so on. But I think especially with the respect of diagrams, it boils down no matter if it's internal for your company or for your development or externally. So I want to tell you 2 little documentation use cases probably all of you came across. I definitely did. I didn't think about them. They were from Adam Scott. And the first example, let's imagine you're working in the company, a new employee starts, highly motivated, wants to get his hands on or her hands on your source code. Then she gets at a computer, and what does she do? Of course, she's reading some documentation. You give her some updates. You work a bit, and then something doesn't work. Probably all of you had this situation when starting. What do? Of course, you ask a colleague, yeah, you're right, we've changed this bit, we didn't adapt our documentation. And I think that's quite a common use case, but it underlines the importance of having your consistency, your documentation consistent. Otherwise, it just gets frustrating and it costs time. Another example, you're working on a project and you need some new functionality. You're searching the web and you found a quite cool library. It's fitting your purpose. You download it, you try it out, and then you, of course, might have a look at the documentation and you find, it seems there are some undocumented functions. Stuff is maybe working differently. You don't get an overview of what the library is about, the intention. So you think, it somehow looks unprofessional, let's put it away. And I think these 2 use cases underline the necessity of having up-to-date documentation and also documentation that's intuitive to read and fast to understand. Adam Scott also points out 8 rules of good documentation. I shortly listed them here, so try to write inviting and clear, okay. Comprehensive detailing at all aspects of the project. Being skimmable, I think that's something to easily skim through it with new technologies when not only having PDF documents but also HTML or whatever. Their users don't read from the beginning to the end but have different sections just to skim over. Maybe examples are useful. Repetition might, especially in documentation, be useful some now and then, but of course they have to be kept in sync and the overall documentation has to be kept up to date. Documentation should be easy to contribute to and easy to find. And the 3 points I've highlighted here, I think they fit quite well to the part of diagrams we talk about in a minute. So inviting and clear, I think diagrams, they provide a clear intuition of how or they're easy to read. Being up to date, that's an issue. We'll see how to address this, and easy to contribute to. So also if you include diagrams, they should, no matter who's contributing to the documentation itself, they should also be possible to contribute to the diagrams. So benefits when having consistent documentation and using diagrams. So fast understanding of your intentions, okay. It looks quite professional from outer perspective. And when you have to draw diagrams, they also enforce you to express your intentions in a clear way. So by the process of drawing diagrams, you have to think about what you actually meant. So now let's get into some examples what I mean with diagrams and code visualization. So I don't want to point out here the best way to draw explanations for your software is this and that. So whatever you like to draw, feel free to do so. Nevertheless, I think in software development, there's a common language of diagrams and their connections, which is UML. Probably most of you know them and stumbled across most of this. So that's also the next part of my talk. We'll mostly focus on UML. And here a short overview of which type of UML diagrams are available. On the one hand, we have the structural diagrams, which represent some building blocks of our software, how it's structured. The other diagrams are the behavior diagrams. So how does the program interact, evolve over time? How is someone interacting with our program library? There are many diagrams below them, below this structure. You've probably stumbled across many class diagrams also during this conference already. Deployment diagrams might be useful to express what is running where in the end. But on the other hand, the behavior diagrams, like on very high level use case diagrams to express the intention of your software, who's using it, your interfaces to the systems next to your software. State machine diagrams are useful when trying to visualize what your component or library is doing if you're modeling a state machine. But you probably came across most of them, and we'll see 5 examples now. The first one is a use case diagram. Here, a great system example, okay, doesn't matter, but you see some actors and some use cases and their relation to each other for this system. Now, I've drawn this by hand. That's an option. Everyone can do this. If you're in a workshop, that's quite reasonable, but if you're in long-term software development, drawing them by hand might not be the ideal option. So maybe it's good to have some kind of software for doing that. Okay, so I was using a software. You probably know which software I was using. Our all-loved tool Paint, it was. Here an example of a component diagram. We have in this shopping example, different components and their relation between each other. Okay, now we got a step closer to using software, but here we more or less can only produce binaries. What I mean with binaries in this case, so we store JPEG files or PNG files, and I think none of us likes committing binary files to the repository, so that's also not an ideal option. A better one we'll see later on more often is this example that was drawn by a tool named Plant UML. Here a class diagram, it's the abstract factory pattern you've probably also heard quite often. And we'll dig into this example more deeply. Here an activity diagram, how to get some coffee. Also drawn by software, but in this case just PowerPoint, which is an option, but doesn't ideally fit into our continuous integration tool chain. And the last one, a component diagram, here a smart home example, where different components are deployed on different systems. So these 5 examples, I just wanted to point out what is meant with diagrams in this context. And all examples, if you have a look at them, they allow to transport information quite easily. And there are many options available of how to draw them. Some are fitting better, some are fitting worse to our software development. So just one slide about consistency. to what is meant in this context with consistency. So we, as a team of developers, we develop our software, we release version 1.0, and we release it with a great documentation, including some diagrams to express what is meant. Then we continue developing, and of course we also have to update our documentation for our next release. And this step from getting these class diagrams transformed, that's the main intention. What I mean with consistency, they have to be part of our version control system, of our build pipeline. And let's dig into how to create some of these. So the intention here is clearly draw diagrams by using code, just as you're using code for your source code, for your tests, for your build pipeline. And this allows you to keep them in sync with the rest of your code and your documentation. So the examples I now show you will draw some stuff by using code. And I'm just using available tools. Many of you are probably using Doxygen for creating documentation more or less automatically, CMake as a build tooling, and Plant UML for drawing UML diagrams. They are all available. Many of you might use them already, and they are easy to integrate into existing tool chains. So we're using them on our automation pipeline, and they're fitting quite well. I will show two approaches. I've named them automatic approaches versus scripted diagrams. So what I mean with this, automatic approaches are those diagrams or overviews where you don't have to do anything more or less. There are tools available analyzing code, classes, or structures you're having anyhow, and visualize them. So totally automatic. That's one part. But I prefer, or the more intention in my talk is about the scripted approaches. So where you're drawing something that's not directly expressed in code, but draw that by using code for drawing diagrams. So I've created a short example. It's a race game example. I just present the directory structure, and the rest of the talk we'll use this example to draw diagrams. So the directory structure, we have three libraries called Vehicle, Traffic Light, and Vehicle Garage. Then we have two executables, a Vehicle Creator and the race game, and some additional stuff for CMake and our documentation. These libraries, I've now created a PowerPoint slide to represent them. Now here we have different targets. The 5 libraries I've explained, an executable or 2 executables, a dynamic library, here another dynamic library, and a static library. And if you can use CMake, and I think many of us are, exactly such dependency graphs can be automated by CMake. In the end, the dependency flow of this generation is the following. So you just write your CMake list files, your targets, define them. Then you use CMake with some special arguments to create a dot file. A dot file in the end is some textual representation, and you can use the GraphWiz tooling to transfer these dot files into images like PNG, JPEG, or vector graphics. And the nice thing about it is you don't have to do anything. This part you can automate with your build tooling, and the CMake targets, you just use them as you have already. So here, a little code snippet. So you can, if you're using CMake, you can create a custom target. And for CMake, the special argument, the very I did not see it very often, but that's the argument to generate a dot file, and it generates it in the current working directory. And the second command uses the dot tooling, which is part of the GraphWiz package, to transform this generated dot file into an image. In this example, a vector image. Now, a short example of how this looks like. Here I've created a Doxygen overview page for this talk. We'll see this some more often. And the dependency graph that's generated by CMake looks like this. So we have our executables again, our dynamic libraries and our static libraries, and you see public and private dependencies. Now to underline, we just add another target. It's an executable called Garage Viewer. Okay, let's rebuild it. I just run CMake build again. And let's have a look at our documentation. We now have this additional target. So this gives you a quite nice overview about CMake target, which might represent the structure you either want to visualize for your internal development or for your library users, which is quite reasonable. So, CMake is not the only tool that can visualize something. If we're now using Doxygen anyhow, Doxygen has some simple options to visualize stuff. On the one hand, they call it collaboration diagrams. So it's just an option in Doxy file you can enable. And then you get something like class diagrams for your classes, showing their methods, their members. So that's a pretty easy approach if you can use Doxygen or any Doku tool building up upon Doxygen. And next to collaboration diagrams, there are include graphs. So that's on a file-based level. Doxygen can also generate them automatically to give you an overview of which files are included. So here in this example, vehicle HPPs including vehicle exports and chrono. And vehicle HPP is included by the vehicle garage. So vehicle garage is using the vehicle. Yeah, you get them for free. So I emphasize you to use these visualizations also. So that's it for the completely automatic approaches. Now let's turn over to the scripted approach. The UML diagrams. There we are using a tool called Plant UML that's also freely available. And the idea is here you describe your diagrams within a very simple syntax within UML or Plant UML files. You can commit them to your source code repository, and the second part of this pipeline can be done by your build tooling. So you use this Plant UML tool, generating diagrams in vector or pixel format, and use them into within your documentation. So the 5 or 6 examples we've seen at the beginning, I've all drawn them here with this tool. So it's and these are not the only options it offers. So it gives you quite quite a lot of possibilities to draw UML diagrams. So I'll turn over now to the demo, showing you, let's draw something together. And we are here using Visual Studio Code, which is, that's, I think, one of the Swiss Army knives. Usually we are developing with Visual Studio or on Linux with GCC. But for many tasks, we're now using also Visual Studio Code, and there's a great extension, the Plant UML extensions, which we'll see in a minute how they fit together. So for our race application, let's close this one here. Let's draw a use case diagram. So far, our use case example here, we want to draw within our documentation some use cases. Currently, it's quite empty. And let's start with defining some entities. So now, the syntax I'm using is this Plant UML syntax. And let's name an actor called gamer and an actor developer. And we have some use case like play the game, develop the game, and maybe we have to write some documentation. Okay, now we're writing this. I know the syntax. I think it's quite easy. You as C++ developers, that's a no-brainer. But the extension allows you just to preview what we've written so far. So you get a live view of what you're typing. Now let's wrap that stuff into a rectangle. That's our race game. Yeah, with some less stuff here. And define some relations of between the actors in our use cases. Now let's say the gamer wants to play the game. Now we want to define a relation, so we can say the use case play the game. We want to access this use case as play, as develop, and as doku. And now our relations look like the gamer plays the game, the developer develops the game, and we as developers have to write the docu. So roughly that's representing our use case diagram. Now it might look, I don't really like this approach of many arrows going left to right, so there are some options to do some layout. Let's say we want the play being above develop, and develop being above doku. Yeah, no, that's how I prefer it. That's it so far. So now we have a pretty simple syntax, a planned UML file we can commit into our source repository, having those diagrams. And there are, of course, some options of how to style it. So if we want to, they're called skin parameters. In this arrow color gray, we want some gray arrow colors, and okay, they get gray. You can also, so the planned UML tooling, it has some pre-processor functionality, so you can include different files. I'll come back to this one later, but in this case, we can, for example, include, I've written one style file named iUML, and we can update this one. And now it's gray. Okay. And if again building it, we see our example reflecting our the documentation reflecting our example. So I really like this approach of having minimal textual representation and allowing to draw diagrams to express some intentions quite clearly that are not expressed in the source code itself. So Doxygen does not only has plant UML support integrated, but you can also use plant UML within Markdown files in Doxygen, for example. So this is an example I'm showing here where you're writing your text in Markdown file, have a plant UML diagram in between, and it just renders the overall page within Doxygen. And I think even GitHub has this support of plant UML within Markdown files. Yeah. So one more word about consistency. So although we now have the possibility of storing our diagrams within our source code repository, there are cases where we might define, where we might use, for example, a class in one diagram and in another diagram, and then we again have the issue of keeping those instances up to date. So there's a little possibility within this tooling of achieving consistency. So in this example, let's assume we have 3 diagrams and outputting 3 images. Now, each diagram uses a class called product, and if we redefine our product, we have to redefine it in all 3 places. So what we can do, we can exclude them in a separate file and include them and use them. That's possible to with to some extent. The same we just did for the style inclusion we had. And I would like to show this also, this approach. So back to our overview page. Here we have the consistency example. Now you quite into that already. We have a markdown file which has some text, then includes one plant UML file, another text including a different plant UML file. So just as an example, let's open this product diagram. It's this one here, and define the class in some way. We have a test method, we have a private member, int counter. You can also add special lines in between our public methods. Okay, now that's just an example of how we might define our diagram. But if we now rebuild our documentation, you know what's coming now. We have this change reflected in the upper one, in the upper diagram, but not in the lower one, where we have the same, or we want to express that's the same class we're meaning. So no matter if you're drawing classes or use cases or whatever, you can exclude this file or define it somewhere else. Let's define it in this one here. And here you have the possibility to draw several diagrams and mark them with a special identifier. So now whatever you're writing here, no matter if it's a node or if it's a sub-diagram or whatever, you can access from elsewhere. You can also write some functions here. So you can call functions and express it this way. Now within our example, we say include classes. And now we are referring to product. And I think I should store it. Now let's rebuild. And you can see, as the other file did already include this dependency, you can see it's now reflected on several levels. So we've excluded parts of our diagram. So we don't only have consistency by storing textual diagrams within our source code repository, but also within diagrams we can reference certain patterns here. Exactly. So that was a rough introduction into the plant UML syntax. You've seen the examples. So not only use case diagrams, class diagrams, but also deployment, timing diagrams, and so on can be drawn using this approach. So as a summary, great tooling for drawing diagrams is already available. It's freely available. Probably you already using some of those tools, and it even integrates quite nicely with CMake and Doxygen. So the takeaways in Outlook. On the one hand, the golden nuggets, again, visuals are key. I quite agree to this, and if you can use them in your documentation, try to. Draw diagrams as code, not as JPEGs, and store them in your repository. So I think those are the two big ones. So great tooling is available, Doxygen, Plant UML, Graph with CMake, and Visual Studio Code in this example. We've achieved that we can have single source. So all our sources are stored within the version control system, and even we can exclude certain parts of the diagram and include them by diagrams that are using this one. And it's version control. So when we go back to the original intention architecture diagrams. So there might be architectural decisions why we want to realize it this way or the other way around. And the nice thing is, if you have your architecture documentation within your repository next to your source code, you can always refer to a certain point in time, go back to version 1, to version 2, or wherever you are, and you have your overall documentation synced with your code. And I also think through to the usage of within that tooling, I think it's quite fun and easy to work with. So try it out. I think there's not much stopping you from using this. What's still open, some further things to improve. I think Doxygen, if you're using it, it has quite a nice feature, that's the name resolution. So whenever you're referring to a certain function, to a class you've documented, Doxygen can automatically generate links to this, which makes your documentation quite skimmable. And that's also one nice to have feature when integrating it in Doxygen. There are some possibilities. I just shortly want to highlight what I'm meaning with this. So here's another example. Now we've directly written all that stuff in the header file. So that's an automatically generated page for the race game header file. Maybe I shortly show the header file. So here, in this example, you really see that's a HPP file, and we have default Doxygen documentation writing the diagram within the documentation. And in the end, you get this as the output. And the Doxygen name resolution allows you to, for example, here automatically generate a link to the race game class if you type race game. It's possible to place links here, but currently there's no Doxygen support for creating these links automatically. So I have a first prototype. It's not yet committed to the Doxygen repository, but this might be possible to include this automatic name resolution here within the diagrams you're drawing. You also have in Doxygen several possibilities of how to include them, and links are working only, of course, if you have vector-based diagrams, as in this case. Another thing, I think reference of header files. When I was showing these talks to or this talk to my colleagues, one intention was, when working with classes, why do we have to redefine them? And I think that's a good point. On the one hand, these scripted approaches of how to draw diagrams, the main benefit from my point of view is if you can document stuff that's not reflected in your source code. But if you're want to draw diagrams, like the factory pattern example, then you most often reference some, or you're using names of actual classes you're using within your project. And here a great benefit would be to include the actual header files, use them within your class diagrams, to not having to retype all your methods and functions, but that's currently up to now not yet possible. Okay, I think I'm a bit ahead of time. Nevertheless, I think we have some further time for questions and discussion. Thanks a lot for your attention.
Thank you, very explanatory and nice presentation. I have just a question about the include and embedded UML. Is it possible to use both for consistency? Because you have the class, and if you embed the class in your class C++ file, the UML part, and the usage in another place, and can you also include there the embedded one?
Embedded one, you mean?
I mean, in the C++ code, in Doxygen, we have seen that you have the plant UML.
Yeah, So also in the Doxygen, I think I can shortly switch over. Also in the Doxygen, here the example I've included the style. So this also works within Doxygen. Of course, you have to pass Doxygen the right search paths, like C++ header include paths. In this case, some include paths for where it can find UML files, but you can also do the same thing, like referencing externally defined diagram parts within Doxygen itself. That also
like include C++ file, which includes which has the class. Is it possible?
No, that's what I meant with the header files. You can include actually any kind of textual representation, but currently that doesn't really make sense to include the header files, because the plant UML just then includes the overall syntax, which you can draw or represent, but that's probably not what you want, because you want just only the methods to be included, and that's not possible at the moment.
And another question: I tried to find any tool which by which you can use the railroad diagrams. Do you know some of them?
No, unfortunately, no. So the diagrams I was showing here, they are mainly they have been the UML part that's supported by Plant UML. I think if we in our team have to draw different diagrams, we use some Python tooling. There are great libraries available called, I think it's matplotlib. That's the Python library, but you have to do some more effort to integrate it into build pipeline, and the approach is a bit different. So it doesn't offer the clean syntax and the easy to read syntax as these UML diagrams show now, but there you have lots of possibilities to draw any kind of different diagrams. Also, if you, for example, want to plot some timing diagrams which are not plant UML conform or whatever, in the end it's just a tool you have to integrate into your build pipeline, outputting some file, but Plant UML doesn't support such diagrams. Yeah.
Thank you.
You're welcome.
So thank you for the talk.
Thanks.
I have a question which kind of continues the first question regarding the inclusion of already existing class diagrams. So I understood it's currently not possible. What do you think? Or what tools or what things would need to be changed for? Let's say I could write a simple diagram. Please, I want to visualize the collaboration between these three classes, and I only want to have like all the methods which I'm inventing, which starts with letters A, for example, because they are the only ones which are relevant for that collaboration.
Yeah. So in the end, you need to have some kind of parsing of your header files in this case, and if you want such fancy expressions, then the parser of these header files need to support it. So I've shortly showed the intention of this name resolution within diagrams. Here the approach also might be that you extend. So Plant UML, for example, offers the possibility to create diagrams including links. So that's what you need for this combination, and it can be realized, as I've done with the prototype, to extend the diagram you've written, to parse it, check if there are classes you're referencing, look at the Doxygen class table it already has, and set the link accordingly. So in the end, what you're doing, you're extending the Plant UML description file with automatically generated links. And the same approach might be possible, that you extend the Plant UML syntax, for example, to include header files, but then you have to parse it with your starting. You want every function starting with test, then extend your Plant UML diagram description, and if this is finished, give it over to draw the diagram. This would be a possible approach.
Okay, thank you.
You're welcome. Any further questions?
So first of all, thank you for the talk. I wanted to ask, so it seems that this is mostly toward internal documentation. Do you have experience using these tools also for customer or external documentation?
So you're right. We're mainly using it for internal communication, but it depends which kind of, or what is internal to your product. So if you're developing a library and having examples of how to interact, something like this diagram I've shown at the end. So here also, if your product would be the race game library, this might also be a diagram that's relevant to users of how to interact with different components. Or, for example, if you imagine I think there were great talks about the Chrono library. If you have an overview of different packages or elements within the Chrono library, that's also relevant for a user. So it depends a bit on what the end user of your product is. So there might be some diagrams relevant for the users of your documentation. The examples we've now seen, they were more intended for the internal developers, but I think the border is here not very clear. Yeah.
Thank you.
Welcome.
Hi, thanks for the talk. I also have one question. How do you make sure that all those documents are actually kept up to date?
Yeah, so that's...
can you share experiences from your company, maybe?
Yeah, that's a great question. So that's similar to the question, how do you ensure that a written comment above your function declaration is up to date? And that's pretty hard. Yeah, it's currently we don't have an automated way of doing this. There might be little options like if you think about, let's assume we have this name resolutions within diagrams, you're referring to a no longer existing class, then you might get a warning. Okay, but that's far away. So that's there is currently, I don't think, an easy solution to this one. Because it's the same problem like with every comment. In this case, the comment is visual or only partly written in code. But keeping this up to date is still a challenge, and it's the same issue with textual comments. Yeah.
Okay. Thanks.
Welcome.
Maybe we need some sort of clang tidy check or something that checks if you touch that file. Maybe you should touch that.
Yeah, maybe that
as well.
Exactly. Yeah. That would be a nice idea. Yeah, having.
Thank you very much for the talk. I would like simply to continue the previous question. So let's start with the comments in the function. So presume I'm the new colleague of you, and I am working on a function, existing function. I modify and I put some new comments. Okay, then I must also change. In this particular case, you are shown on the screen. I must, as I've seen there, you must rearrange the lines, the comments in the drawing description in the files, as I remember. So yes, exactly. This part should be put in sync. Let's presume I put some new function, I put some new comments, and I must add also there a line. And the question is to put a comment in a new function or a new functions. It's already a tradition in development. Please tell us how you convince the new colleagues coming and making some extension of your existing code to comment, because comment in the documentation is very good, it's high quality, but he must also change that part of the code.
You're absolutely right. And I think here the main argument for this approach is the easy tooling setup. I think what I've shown, in the end, the tooling you require is the Visual Studio Code, including this extension. And from then on, I hope we get some signal back again. So if you have this, you can even, we shortly see it, in the header file, having the diagram and directly visualizing the diagram, even if you're working on the HPP file. Not only if you're working on the plant UML file, but you get this live preview also within if you're working on the header file directly. And so I think the burden of getting started, or the hurdle, that they are quite low. So this might be not an easy option even for newcomers to get into that. Of course, I agree. It's new syntax, it's additional tooling, so it doesn't come for free. But the burden is quite low.
So you convince them to adhere to your concept very quickly, and from your experience, the new colleagues see a lot of advantages, and they very quickly say, "Okay, I'll do it as you ask."
Exactly. So one of the summary points, it's quite fun to work with, and that was also our experience, that newcomers seeing the kind of documentation, they quite saw the benefit of not only having 10 lines of written text, but having one diagram as quite beneficial. Yeah.
Thank you very much.
Thanks. Any further question? So again, thanks a lot, and have a good day and further talks.